right, ladies and gentlemen, so just a reminder that I will be available for early morning help tomorrow, but this is what your test is going to be like. So our first two topics were being able to graph quadratic equations and find the roots from them. So if you look, right, if you remember in a quadratic, C is always your y-intercept. So if I'm trying to match, you first of all could plug these all into your calculator. But if I look down here, we're crossing the y-intercept at -12, which means I can automatically get rid of C and D. And then you can just find a point, this is the point 36, and plug it into either problem to see which one works. It ends up being B, and again, I'm going to tell you, just to save some time, you could go right on your calculators to do that. Axis of symmetry, you need to know that, it's -b/2a. So when I'm looking at my equation, A is 2, B is -12. So negative of a negative means I have +12. 2 times 2 is 4. So my axis of symmetry is 3, which gets rid of A and B. And then I'm going to plug this in to get my next value. So when I put 3 back into my equation, this is going to be 2 times 3 squared. Again, you can put it in your calculators. I'm just trying to save some time. So that's 9 times 2, that's 18, minus 36 plus 6, which should give me a -12, I believe, if I did that right. So then the point would be 3, -12. Okay, find the coordinates of the vertex. Identify the vertex as a maximum or a minimum. I already know it's a maximum because it's flipped over. So when you have one like this, your vertex is going to be a maximum, which means I can already get rid of A. So we can try to eliminate some answers. Again, I'm going to use -b/2a. In this case, there's no b because I don't have an x term, which means b is 0. So the only one that has 0 as for a vertex is choice D. If there was more than one, then I'd have to do like I did back up in number 2, put the x value in, and then go from there. What are the roots of the quadratic equation? So when I'm looking to see roots, solutions, zeros all mean the same thing. So it's where it crosses the x-axis. It crosses at 0 and 1, 2, 3, 4. So 0 and 4 is choice C. Number 5. One root of the quadratic equation whose related function is graph lies between which consecutive integers? So this one is between -2 and -3, and this one's between 0 and 1. So now we're just going to look to see, well, which ones make sense? Choice A is the only one that works there. All right, next page. Use a table of values to graph the function, y equals 2x squared minus 3x. You plug that into your calculator, you're going to get a table of values. So it's kind of up to you which ones you choose to use. I'm going to show ones that I know for sure fit on the graph. So -1 and 5, 0 and 0, 1 and -1, 2 and 2, 3 and 9, and then I think that'll be about it. So -1. Now, if I want to know where my axis of symmetry is, so in this case, I have my -b, so this is 3/4. So my axis of symmetry is going to be somewhere close to 1. So it's not going to be an actual turning point. So if I have -1, 5, 1, 2, 3, 4, 5, and 0, 0, 1, -1, 2, 2, and 3, 9, I didn't even fit on there. So again, my axis of symmetry is going to be somewhere over here. So when I graph this, your turning point should be a little bit to the left of the -1, 1 point. Okay, solve by graphing and if the integral roots. So when I do a table of values, I get 3, 6, 7, 6, 3. So -1, 3. Again, I put that into my calculator. 0, 6 isn't going to show. It would be way up here. 1,7 isn't going to show. It would be up here. 2,6. And so this really wasn't a good graph for this part, but if you do this, when you connect them, we get that our number, or our root, is between -2 and -1. And then between 1, 2, 3, between 3 and 4. All right, so it's in between those two. And again, I'm not going to make you do that big long chart to get it to the tenths. That's just a little ridiculous. Solve by factoring. Factoring means one side has to be equal to 0. And then I need to find factors of 27 that subtract to give me 6. And if you want to do your factor sum, but it's 3 and 9, so not +9 minus 3. And then we set each of those equal to 0. So x is -9 and x is 3. Okay, describe, now this one's a little bit tricky because we're not comparing it to our x squared, we're comparing it to 5x squared plus 1. So if I take, and I notice, first of all, it's a -5, which means it has to be reflected over the x-axis, which means I can get rid of at least b and d. To then go from 1 to -2 means that I'm going down 3. So that should be choice C, reflected over the x-axis and down 3 units. Next one, very similar. How is it related to x squared? So this tells me that I have to go down 3, which is choice A. Describing this one, so out front is a vertical stretch. Right, I just go in order. Stretch. The -4 tells me, now remember when it's inside the parentheses, that's the one that's the opposite. So this is actually right 4. And the -3 means down 3. Okay, find the value of c that makes this a perfect square trinomial. That's when we have to take half of b, which is 5, and then square it, so 25, choice D. Which is not performed when solving, so you have to kind of look at these. But when we're doing it, we never factor the trinomial the way it's given. So we never do that. Which equation is equivalent to this? So they want you to kind of basically go through and do your perfect square factoring. So first thing I would do is divide everything by 2. So I'm going to have x squared minus 12x minus 7. Now I need to, and I know I'm kind of going into this part, but I need to add 7 to both sides in order to do my perfect square trinomial. Then I need to do half of 12, which is 6, which means, again, automatically I can get rid of those two things. And then I'm going to square it, so this is going to become x minus 6 squared. Half of 6 squared is 36, so I'm adding that over here, which is the 43. Choice D. Solve this by completing the square round to the nearest tenth if necessary. So I am going to take and divide everything by 2. So this one does get a little messy. X squared plus 4.5x equals 9. Then I need half of 4.5, which is 2.25. And then I'm going to have to square that and add it to both sides. So 2.25 squared is 5.065. So this is going to become x plus 2.25 squared equals, and again, I'm trying to save some steps, plus 9 plus 5.0625. So if I add those together, right, this is x plus 2.25 squared. This is 14.0625. I have to take the square root of both sides. which is 3.75. So x plus 2.25 equals plus or minus 3.75. Then you're going to add the 2.25, subtract. So I'm just going to finish telling you the answers for that one because I'm just trying to save some time here. So you should have gotten, if you did this correctly, -6 and 1.5. Okay, so you were adding 2.25 to it and subtracting, or doing a positive and doing a negative. Determine the number of real solutions. This is where you do your b squared minus 4ac. Right, you just took a quiz on this the other day. So b squared, b is 5, so that's 25 minus 4 times 1 times -6. So 25 plus 24, so it's a positive 49, which means there are 2 real solutions. Two numbers have a sum of 4 and a product of -5. That really has 0 to do with it. This should say find the quadratic formula. So we have -b plus or minus the square root of b squared minus 4ac all over 2a. This side has to be equal to 0 if you're going to do this. So a is -1, b is 4, c is 5. And we're going to put those numbers in. So -4 plus or minus 4 squared minus 4 times -1 times 5 all over -2. So -4 plus or minus 16 plus 20 all over -2. 16 and 20 is 36. The square root of 36 is 6. So I have -4 plus 6, which is 2 over -2. And I have -4 minus 6, which is -10 over -2. So when I solve those, that's -1 and 5. So those are your 2 answers. So that one could have been done by factoring, but that's not what the directions said. All right, next one. Whew, almost done here. Determine which model linear. So we're going to look first for our differences. This is going by 12. This is 20. And then this is 28, hopefully. So it's definitely not linear. Second ones were, which means it's quadratic, which means I need the form y equals ax squared. Okay, I'm going to pick one of my values. I'll pick 1 and 4 because it's easier. So 4 equals a times 1 squared. And so 4 equals a. So my equation, 4x squared. Determine the domain and range. Your domain are all reals. They should be put in fancy brackets. Your range, all y such that, and if you look, your lowest value here is -3. Y is greater than or equal to -3. Piecewise function. So we're going to graph. I have x plus 2. So that means I would normally start at 2, right? So you would be doing this in pencil. And we're going to go, my slope is 1, so I'm going up 1 over 1. And my board's off, I apologize. But it only wants it for values that are less than 1 for x, which means I don't need these 2. And at 1, it should be an open circle because it says less. Oh, I did it wrong. Sorry. That's what I get for not paying attention. How about we try that again, where now we have them so that they're greater than, which means I don't need this point, and this one should be an open circle. So we're going this way. 2x minus 1. So if I start at -1, my slope is 2 over 1, so I'm going to go up 2 over 1. And this time I want less than or equal to 1. So I want from here, let me get some more points, from here down, and that is a full dot. And again, I apologize that my board is so messed up. So that's your test. Questions, I will see you tomorrow morning. Have a good night.